Today we're once again considering computation expressions, and we've seen in a previous video the expression that I'm showing you here. This is a logging builder that we built to be able to log values as we execute our program. To quickly recap, let's execute this and see that we have some of the statements here in the code. They automatically get printed because of the code we injected. And we talked about the bind function in the previous video, which essentially lets us inject some additional stuff that we hide from the application of the computation expression. What I want to focus on today is the return statement here, or the return function. This function in general is something we're not always used to seeing. So when we talk about computation expressions, we have this return keyword at the end of the thing that we produce, but we're not really used to seeing that in F#. If we define some normal function, if I just say add x, let's see, x, y, I would not put return here. I would just say x plus y. That would be my function, and this works perfectly fine. In fact, if I try to put return here, like this, you're going to see that we get an error. It doesn't figure out what to do with this. F# does not expect us in general to provide return statements when we define normal functions. But in computation expressions, we do. And the reason for that is when we have this kind of return, what F# will do is it will wrap it into the corresponding computation expression type. So if we have a computation expression, and we're going to have a look at async now actually to already have the framework to discuss, you're going to see that the thing we use return on actually gets wrapped into an async. So let me remove this code that we looked at before, and I'm going to now implement something using the async framework. So we're going to define a very simple function, divide async, like this. It's going to take a numerator and a denominator, like that. And the implementation here would be the following. So we will use the async computation expression this time. And in here, I would simply say return, and I would divide these two numbers, like that. You can see everything looks fine. What I want you to pay attention to now is the signature here. So when we define this, we take two integers as input. You can see first integer here, second integer here, and what we return is an async of integer. So this thing here is an integer, but what the return function does is it actually wraps this integer into an async. And if we look at the documentation for this, I have that open here. So you can say async builder, which is the one we're using here, has this return function, and it creates an asynchronous computation that returns the result v. And you can see in the value that's passed here that this has some type, and the return is an async of that type. So what this return does is it takes the type and it wraps it into an async. Now, the natural question you would have is, why does it do that? It seems unnecessary to wrap it into an async. When we have the number, we want to return the number. Why don't we just return the number? Why do we need to wrap it in an async? And the reason for that is it integrates a lot better with computation expressions that we might define in other places of the code. So let me illustrate this by another example. So we're going to define another function here. It's going to be called let divide by 2 async. So divide by 2 async, like this. And it's just going to take one value, like that. And what I'm going to implement is, again, async computation expression here. And in the body, I'm going to say let bang result equals, and here I would use my function from before, divide async, like that. I would take my value and I would divide it by 2, like that. And after this, I would return my result. Okay, what happens here? You can see that we call divide async up here, and this in turn is an asynchronous computation. Now, in this case, I'm just dividing two numbers, so it doesn't really need to be asynchronous, but you could imagine that we're fetching some stuff from a web page or whatever. So the computations in here are asynchronous per default and follow the type of this async. So the thing that we return, if we now just use the value here, this is itself an asynchronous computational expression, right? You need to potentially wait for some things to finish for the computation here to finalize and for us to get the value. And for that reason, we need to use this let bang syntax. So when we make use of this, we would expect to use the let bang syntax. And if this thing was not wrapped into the appropriate type when we get it back, we wouldn't be able to use it. So F# wouldn't understand in that case that we are actually doing asynchronous computations here and that we need to wait for that to be finalized and for us to get the result. So what happens here is we now have this divide async. It returns something in the appropriate type because this computation expression here that we're trying to execute is now an asynchronous computation. It's not an atomic computation that you can just execute at the very exact instance where you get the call for it. So it needs to be wrapped in the appropriate type. And once we have that, we can use the let bang keyword to store this in result. And then we can return the result. And then again, the result from this function, because we use the return value here, is again wrapped in an asynchronous value. So if you look here, we take an integer as an input, and then we have async int as the return. Because remember here, result is an integer, and then we call return on result, which wraps this result into an async. So result is integer, it's getting wrapped into an async int, and if we look at the signature here, that's also reflected, right? So the last thing I want to tell you is, let's say we have another form of computation expression where we actually get an async on the final row. So let's say instead of defining this intermediate variable here, result, we actually would just execute this directly here. Now this becomes slightly problematic because if you look at this part right here, this thing will already have the type async of int. Because this thing, because we're calling the function here, you can see that it takes two integers, and those are the ones we provided here, value and 2, they're both integers, and it returns async of int. But if you paid attention to the return function, you know here we have async of int, but then we call return on that, so we will wrap it into another async. And what you will see in the signature here is now the return type is actually async of int. And this is a problem because when we link computation expressions, we don't want them to nest into hierarchies of these async. We just want one async to tell F# that this is an asynchronous computation. You need to be aware that it's not atomic. It doesn't finalize as soon as we make the function call. You need to actually wait for this to finalize. What can you do in this case? Well, luckily, there is an alternate syntax that's very similar to return, namely return bang. And this does pretty much the same thing as the let bang and the do bangs that we've talked about before. You have some asynchronous value here. This thing now takes that appropriately into account. That's the way of thinking about it. What happens behind the scenes here is instead of wrapping this in an async, we just return the actual value itself. So before we had a nested async, and if you look at the signature here now, you can see that that disappeared. So this return bang is a way of treating the code or treating the behavior when the thing that returns here is itself an asynchronous computation already.